So this is the Perseverance rover moving its head, and it's looking at its traveling companion, a helicopter on the surface of Mars. So thank you everyone for being here this evening. As Stacy said, my name is Sarah Marcotte, and I'm coming to you from the Jet Propulsion Laboratory in Pasadena, California. We do a lot of Mars operations here at JPL, and I've had the privilege to work here for almost 18 years, most of it with the Mars program. Now, my kind of beat was working with science museums and public events, but I've had, such a great time meeting many Mars scientists and meeting many people across our entire country with, trying to share the excitement of Mars exploration. So I'm going to take you kind of in a whole overview, a history of Mars exploration. I promise I won't bore you with 60 years of details, but I'd like you to know what a long history NASA has actually exploring Mars and humankind's interest in Mars. And the way that we explore Mars is both from Earth, but we have been sending robots there for 60 years. So I'd love to tell you about these robots and spacecraft who have made these discoveries about Mars possible. Many of them, everything I'll talk about today is from NASA. There are other countries who have been exploring Mars, but I'll keep my focus on the NASA robots that we know and love from our agency. So I will begin. All right. So, of course, humankind has been engaged in looking up at Mars for thousands of years. Of course, the planets were well known to ancient people. And when telescopes were invented, people were able to see Mars and really able to look at its surface and wonder about it. So starting in the 1600s with the invention of good telescopes, people were noticing that Mars had different colors and shapes and sometimes had more detail and other times had less detail. So a lot of interest and curiosity about planet Mars, because we could see these intriguing features, was happening, especially in the 17th through 19th centuries, when people were able to see that Mars had dark patches and light patches, and people were, making sketches of it, wondering were there oceans. And of course, you may be familiar with the name Percival Lowell, who was a person who popularized the idea that Mars might have intelligent life. He was interpreting these lines on the surface of Mars as canals. Other people were thinking he interpreted an earlier astronomer's word canali as canals, but maybe that person was saying channels and wasn't thinking intelligent life. Anyway, there was a lot of debate and discussion about what was on the surface of Mars. Were there oceans? Were there intelligent beings? Were there cities? So a lot of interest. And so in the 1960s, as NASA was working on sending spacecraft to the moon, they were also working on sending spacecraft to Mars in late 1960s. So just last month, on July 14th, 2025, NASA celebrated the 60th year since Mariner 4 flew by Mars for the first time. So this was the first time a spacecraft had taken pictures of the Mars surface. And everything kind of changed. People were wondering if there were cities or vegetation or oceans on Mars. And Mariner 4, which flew by in 1965 in July and took 21 shots, 21 photos. It returned pictures that caused everyone to think, wow, there doesn't look like there's the possibility of any cities or oceans or canals or anything on Mars. This looks like a dry, lifeless planet. Mars looks like our moons. So this was the first time, 60 years ago, that we got images of Mars from Mariner 4. And it ignited a lot of scientific curiosity, but it did kind of dash people's hopes about whether we might have some other intelligent life in our solar system. Here are some more images taken by Mariner 4. So they were able to learn quite a bit about Mars even from these atmospheres, figuring that Mars probably has a thin atmosphere because there were so many craters on it, like our Earth's moon. So they just kept sending spacecraft to Mars after that in 1965. So since 1965, we've had almost continuous robotic exploration about Mars, and I'll be telling you about those robots today. Now, here are 5 spacecraft that are not the only spacecraft that have gone to Mars, but these 5 I will be talking about because they represent the firsts in our exploration. And NASA followed a program of exploration both on Mars and elsewhere in our entire solar system. You know, we visited every planet and asteroid or, asteroid belt in our solar system. And we followed a progression building on what we learned in earlier missions. And that involves, especially in the case of Mars, flying by a planet, going into orbit around a planet, and in the case of Mars, landing, roving, and then flying at the planet. So these are the 5 spacecraft that were able to do those milestones, those firsts in Mars exploration. Not the only spacecraft, and I'll show you many more other spacecraft we've sent, but these were the first. And each one of these spacecraft broke new ground for other spacecraft that came later. So I give them props for, sort of breaking these barriers that enabled more exploration. So I want to give you a little context about Mars, just so you see the environment that these robots have to operate in. So I would love to spend the next 2 slides giving you sort of a high-level overview of our friend Mars. So the top graphic shows you Mars's place in the solar system. Of course, planets are never lined up perfectly like this, but this shows you the order that our planets are arranged in relation to our sun. So Mars is one of the 4 inner rocky guys, closer to the sun, and then of course you have the outer gas giants. Not to scale with distance, of course, but it does show you sort of these smaller planets and then these huge ones way off, millions and billions of miles away from the sun. So Mars is quite similar in its size and shape and composition as its 4 other rocky friends, including our Earth. The bottom graphic shows Mars in relation to Earth. So Mars is about half of the size of Earth. So it's small. And because of its small size, it has less surface area. Little fun fact is that the entire surface area of Mars is equal to the dry landmass of Earth. If you sort of took away all of our oceans and squished our continents together, the landmass of Earth without oceans would be about the same size as planet Mars. So because Mars is smaller, it exerts less gravity. So if I were on Mars, I would only weigh 29 pounds. Mars has about a little over a third of the gravity of Earth. You could jump 3 times as high. Maybe you could throw a ball 3 times as far, or you could carry something 3 times as heavy. So you would have less, there's less gravity on Mars. We do, of course, take that into account when we're sending spacecraft to Mars. Things like gravity and what the slide I'll get into next, temperature, matter a lot with spacecraft. So what would it feel like if you were on Mars? Well, Mars is cold, very, very cold. Pretty much everything in our solar system is very cold, except our friend Venus, which is way too hot. So Earth and Mars are the only places in our solar system that we consider to be the best places for life. If you imagine Mercury and Venus, they're too close to the sun. Venus has a thick atmosphere, it's too hot. Mars and Earth, sort of in a good spot. They're not too close to the sun, not too far away from the sun. Our outer gas giants don't have a solid surface and are too far away and too dark and too cold. But Mars itself is very, very cold. Mars's atmosphere is only 1% of our atmosphere. So it has very, very, very thin atmosphere made primarily of carbon dioxide. So we could not breathe on Mars because of the low air pressure and the fact that it's carbon dioxide. So there is a trace of oxygen in the Martian atmosphere, and that trace of oxygen has caused Mars to be called the red planet because there's enough oxygen that it has oxidized the iron-rich minerals in Mars causing them to rust. So it could be called Mars the rusty planet or Mars the red planet. Now, all that red rock causes red dust, and that's why Mars looks kind of reddish orangish when you look at it in the night sky. Now, the top image on the right, the left-hand side, is actually a sunset on Mars. It's kind of interesting. Martian sunsets are blue. As the sun sets on Earth, our blue sky is filtering out the blue colors, and we have sometimes a beautiful red or orange sunset. On Mars, the opposite is true. That reddish, tannish dust filters out the red, and Mars has a blue sunset. So it would be sort of interesting to see that if you were on the surface of Mars. The thin atmosphere makes very, very low air pressure, but Mars does still have weather. So you can see in the bottom graphic, I've put in a very, very common phenomena on our friend Mars, which are dust devils. These little tiny tornadoes that we've seen with all of our spacecraft scooting along the Martian surface. Now, with its low air pressure, the Martian wind exerts very little force. So you could be in a 60 or 70 mile an hour gale and the wind would not push you over. So it's interesting that it does have wind, it does have these dust devils, does have ice clouds in the sky, but the wind itself is not very strong. Now, a Mars year. Mars is in an orbit around the sun, but if you saw from that graphic before, Mars is farther away from the sun than Earth. So Mars's year is longer, about twice as long as planet Earth, 687 days. So I said before I would only be 29 pounds on Mars. What I meant is on Mars, I'd be 29 years old, which I'll hold on to, and I would be 40 pounds on Mars. So the Mars year is about 2 Earth years. So I'm sticking with 29 for now. So a Martian year, about 2 Earth years. A Martian day is actually quite similar to Earth. When the Earth rotates once on its axis, that's an Earth day. Ours is about 24 hours. Mars is also about 24 hours, a little bit longer, 24 hours and 40 minutes. So sometimes when humans are operating spacecraft on Mars, sometimes they actually try and keep their clock synced to the clock on Mars. And each time their day shifts 40 minutes each day. So it's kind of an interesting thing to be on Mars time. We have had people do that. As you can see in the Mars image, which was taken from Earth orbit, the Hubble Space Telescope, Mars has these lighter patches. You can see the rusty red and these darker patches, which is volcanic rock called basalt. And Mars has polar ice caps, which are made of dry ice or carbon dioxide ice. And they are constantly growing and shrinking according to the seasons. Mars does have seasons. It has spring, summer, winter, and fall because it's tilted on its axis, similar to how Earth is tilted, about 24 degrees. However, Mars's seasons are uneven because it's a very elliptical orbit, and they're much longer than Earth's seasons. So their seasons are about 6 months. So I think about 6 months of winter. All right, so now you know Mars that we're working in. Mars, not a great place to visit. It's cold. It doesn't get as much sunlight, less gravity. It's a difficult place to be. A lot of radiation. However, we keep sending robots there. So after 1965, we weren't done yet. We sent 3 more Mariner spacecraft. Apparently, we weren't very creative with the name of our spacecraft. So 3 were named Mariner. There were actually 4, but 1 failed upon launch. So Mariner 9, this was another first. Mariner 9 in 1972 went into orbit around Mars. So Mariner 6 and 7 did the same thing as Mariner 4. They flew by and they took pictures. They didn't capture these 2 really cool features. They just happened to, sort of get a line of pictures as they scooted by Mars. Mariner 9 was the first thing to go into orbit. So this was a milestone for us, and it lasted about 11 months. And it took these pictures. On the left, the largest volcano we've ever seen in our solar system, named Olympus Mons. There are several volcanoes on Mars, inactive. At least we've never observed in our 60 years of exploring Mars. We've never observed these blow up or erupt. But, this volcano has other volcanoes around it. So this whole volcanic region. So if you took this volcano and plunked it down on the United States, it would cover the entire state of Arizona. Now, Mariner 9 also saw this cool feature called Valles Marineris. It's a Grand Canyon on Mars. It's a huge, enormous crack on the Martian surface that, if plunked down on the United States, would stretch from Los Angeles to New York, 2,500 miles long. That is a big canyon, and it's wider and deeper than our Grand Canyon. This is not a canyon that was carved by the actions of water. It is a crack in the Mars crust created by the Mars shrinking as it cooled. So Mariner 9 caught these two cool features and also a whole bunch of other interesting features. And in fact, when Mariner 9 pulled up at Mars to go into orbit, it couldn't see anything. It arrived during a global dust storm. And we had observed those dust storms from ground-based telescopes. But Mariner 9 got there, and it was like, you get somewhere in your summer vacation and it's cloudy the whole time. So it was able to finally observe Mars when that dust storm settled in. But those are the hazards of going to Mars. We get a lot of global dust storms. This spacecraft was able to map the Mars surface, so that was handy, 85% of the Mars surface. Let's go to our next big group of missions and another milestone. So we've flown by, we've gone into orbit. What's next? Well, let's send the Vikings. Now we're up to 1975. So there's some good music. I love music from the 70s. So there's some good music playing, and we have the Viking missions. Now, how cool were these? These were big, giant, expensive missions, 2 of them. It was a lander and an orbiter paired together. We had Viking 1, lander orbiter, and Viking 2, lander orbiter. Both these spacecraft were sent to Mars in 1975, about a month apart. So the orbiters the orbiters and the landers were paired together. They went into orbit, and they had landing sites in mind that they had chosen from other Mariner 9 images. However, when the Viking orbiters arrived and were going to release the landers, they realized that those landing sites were not going to be good places to land. They could see rocks from orbit. So they decided to choose different landing sites. So these 2 paired spacecraft went into orbit for a while, and they chose different landing sites. So that was a handy thing to be able to look for your parking spot, and then you can release your lander. So Viking orbiters stayed in orbit for years, mapped 97% of the planet, and you can see this is a much better resolution image. As we're sending spacecraft, the cameras are getting better, the computers are getting better. Now we've got these color images. Look at that beautiful polar ice cap. Look at that Valles Marineris that you can see. And the landers. So eventually the landers did release from those orbiters. Both Viking 1 and 2 landers landed on the surface of Mars. And now we've passed another milestone. We've landed, and we've gotten pictures from the surface of Mars. So on the bottom is Viking 1's footpad. So those were one of the first images that came down from the lander. There you're looking at the Martian surface. So the geologist probably went nuts. I wasn't there, but the geologist went crazy because it's the first time you can actually see the Martian surface. And they're, I'm sure, looking at the shape and size of those rocks, wondering how they were formed, wondering if, they've got sharp edges. The geologists look at this, and there's a lot that they see that I would miss. So these Viking landers could take pictures of the surface close-up and then panoramas. So they did have cameras that could see all the way around. And what you do is stitch a whole bunch of images together to make these panoramas. Now, the black areas are just places where the camera didn't capture, couldn't see, or, couldn't capture images. But you can see that that image would sort of wrap around, and you can see the lander hardware inside that image. You can see the horizon a little bit and look at the shadows on Mars and the lighting conditions. So these were exciting, that they were the first time we'd set a spacecraft down. Now, if you look at this spacecraft, one of the landers, Viking landers, you can see the fluffy thing on the left. That was a biobarrier. That was covering some very important instruments on the lander that was retracted upon landing. And you can also see on the right-hand side, there's something sticking up, which is a robotic arm. Now, the Vikings went straight for the biggest question we have in our solar system science right now. Did life develop elsewhere from planet Earth? And it's a big question for Mars. Did Mars ever have life? Well, the Vikings went straight for that question, and they brought a life detection instrument. That robotic arm on both landers was used to scoop into the Martian soil, and then they had a life detection kind of experiment right there on the lander. And then they had, a spectrometer and other computers to analyze those samples and send information back. And for most Mars scientists, there was no life detected whatsoever in this soil, in these samples. However, there was a little bit of debate. Some people interpreted that, well, those readings, they're ambiguous. Maybe there was life. So there was quite a bit of debate about these life detection experiments, and most people were highly disappointed that they didn't find life. And some people thought we kind of reached too far in one mission, like we went right for looking for life. Maybe we needed to back up a little bit and think about all sorts of other things about the search for life that aren't looking directly for life. I'll explain what I mean about that. But the controversy with these life detection and people's disappointment in not seeing life, even though few people still held on to that dream, kind of set back the Mars program for a little while. And they decided to get at that life question in a different way. One reason why people did not, the more they learned about Mars, they believed that life could not exist on Mars, is because it's so cold, it's so dry, the soil is so acidic, and there's a lot of radiation that reaches the surface. So they considered the soil self-sterilizing, that life would not be possible on the surface of the soil because, again, of this terrible radiation coming through, and that liquid water, which on Earth is so important for life, could not exist on the surface. So we wanted to start thinking about, okay, the search for life, or the search for, was Mars capable of holding life in a different way? Let's get into that. So Vikings, 1975 up through the late 70s. And after the Vikings, there was a big lull in Mars exploration and actually in NASA planetary science. Between 1979 and 89, we didn't launch anything. Nothing went to Mars. NASA was kind of going through a thing, and they didn't want to do these huge flagship missions. We'd sent these big Viking missions to Mars. We'd sent our Voyager missions throughout the solar system. We had sent something called Galileo to Jupiter, these big giant missions. And the mood of the country and of NASA was shifting. And they said, why are we doing these big giant bureaucratic missions? Maybe we can do littler missions. So there's something called Better, Faster, Cheaper. Or actually, it was called Faster, Better, Cheaper. I wrote that wrong. This was a time when NASA administrators were saying, let's do lots of small missions. Like, let's not do these big giant things every 10 years. Let's do lots of little ones. And so it was like, can we just stop being so bureaucratic? Let's just send all these things to Mars. Like, don't spend so much time operating them and designing them and, spend so much time on them. Just get them out the door. And that was the ethos at that time. However, there were some failures with this kind of method of having fewer checks and balances, less design time, a more compressed schedule, a smaller budget, and less science. So in the Mars program, we had a series of failures in 1999 and 2000, which were a little heartbreaking. We'd have two successes. These images, these spacecraft that are outlined in yellow, are two successes, and one was a wonderful success and one of our milestones. On the upper right-hand side, the Mars Global Surveyor was a wonderful spacecraft that spent about 8 years at Mars and mapped magnetic fields, which was very important, localized magnetic fields and doing some global mapping of minerals on Mars. And then in the lower left, we had the Pathfinder mission, which was a smaller, faster, cheaper mission, but a successful one. And you'll see the first rover. So let's go to that one. So this is another one of our milestones. We've flown by, we've gone into orbit, we've put landers and orbiters around Mars. Now we've got a rover. So 1997, the Sojourner rover was the first rover on Mars. This was a lander that opened up like a flower, had a little ramp, and this tiny little rover came out. We call it the size of a microwave oven, but we're thinking of older microwaves that are big. So this was, a small rover, but I can hold it in my arms. And this little critter didn't do much because it was kind of a demonstration. Can we drive on Mars? Unfortunately, the place where we put it down was super rocky and it was a tiny little rover. So it had to really navigate around its environment. You can see in this lower image, it's got like lots of things to dodge. But that cute little Sojourner rover proved that we could operate a rover on Mars. This little guy was supposed to last a week and lasted 3 months. And that told us a lot about, wow, this could be another way to explore Mars. That image in the upper right hand is its landing system. This lander with the rover tucked inside was tucked inside this multi-lobed airbag, set of airbags. I think it looks like a raspberry myself, but it was inside these lobes and dropped from the back of dropped from what we call a back shell that had slowed down to Mars on a parachute. This thing was dropped and it bounced on the surface of Mars. And we used this landing system for 3 missions. So this mission and 2 rovers that followed. So it was called the airbag landing. This was an innovation in landing on Mars. So we've had this next milestone. Now we are roving on Mars, and we've sent a total of 5 rovers to Mars, including this one. So after this faster, better, cheaper era, they started thinking, the Mars exploration program, we need to be, and also about, after the Viking, like go straight for the life, and now we're a little disappointed that there's no life on Mars question. The Mars exploration program was born. So this is in the early 2000s. And the Mars scientists and NASA got together and said, listen, we need to have a sustained strategy that's going to build upon some increasingly complex science questions that each spacecraft is going to build on what has been done before and answer a more sophisticated question. So this was a whole strategy that would last for 20 years, and it has lasted. We're actually at the tail end of this exploration strategy. So the idea was we're going to have kind of 3 phases. The first phase is we are going to document and confirm the history of water on Mars. Because as we know, on planet Earth, water is important and critical for life on planet Earth. So on Mars, we're going to document the history and presence of water today or in the distant past. Then we're going to, if we find that there was sustained water on Mars, they already knew there was, but they wanted to know more, then we're going to see if Mars could have supported life. Were there other things that life needs to survive? Sources of energy, enough oxygen, enough sunlight, and water standing for a persistent water standing for a long time. I'm talking thousands or millions of years. So water, habitability, or could Mars support life? And then, only then, if those two things get satisfied, we are going to search for signs that life once did develop in the past. Not today, signs of ancient life. So we've had that strategy for 20 years. The next spacecraft I'll tell you about fulfill this strategy. This critter is called Mars Odyssey. This spacecraft is still working. It got there in 2001, and it is still in orbit around Mars, sending back data. These 3 images are just a few of the millions that Odyssey has sent back. These are false color, so these are not what Mars actually looks like, but Mars Odyssey has the ability to map minerals and the distribution of water and different rock types. And on Earth, when the images are processed, they assign different colors to bring out more rich detail that you can see. So you can see on the left, this is a beautiful crater that has different kinds of rock, and you can see all the features that are assigned false color. So we can kind of see more of the detail and, the different kind of rock units there. The center image are these beautiful sand dunes. There are many, many sand dunes on Mars, which is always a challenge for things with wheels. Our rovers have encountered a lot of problems with sand dunes, sand traps. Like if you're golfing, you don't want to be in a sand trap. Same with on Mars, you don't want to drive through sand dunes. The image on the right is taken near the polar region of Mars. So it shows some carbon dioxide ice and then sort of sand ripples associated with the ice. So Mars Odyssey, still going, still doing science. And within the past 15 years, Mars Odyssey and the orbiter I'll show you next have new roles in that they're data relays for our spacecraft on the surface. So they end up helping send data back and forth from orbit back to Earth, and they help us select landing sites. So if there's an area we want photographs of, these orbiters will do that for us. So they not only do their own science, but they support the activities of other missions and relay data back and forth. So very, very important spacecraft. And since 2001, it's been there a long time. Here's the second one that's been there a long time, Mars Reconnaissance Orbiter. This one's been in orbit since 2005. Now this one has a huge, huge, huge camera. A gigantic camera that is, I want to say, I've seen pictures, so it's probably about 16, the lens is about 16 inches across. It's a very, very large camera. From 200 miles away, it can take a picture of something the size of a dinner table, like a large dinner table. So it has very, very high resolution, crazy camera, and many other instruments to document water on Mars, carbon dioxide on Mars, the distribution of minerals, and environmental change or dynamic Mars. This is something you'll see me talk about later in this presentation. There's a lot that changes on Mars. It's a dynamic, changing, evolving planet. And these are a few images of that change. On the upper left hand is one of those dust devils I told you about, taken from orbit. So that dust devil was scooching across the Martian surface. The upper right hand is a new impact crater that Mars Reconnaissance Orbiter was able to see. That is in false color, but you can see, smack, something hit the planet, and scientists are always interested in the ejecta, or what comes out of that crater, and seeing what interesting things that meteorite scooped from the Martian surface. In the lower left, it's a little hard to see in this image, but that was a landslide. The Mars Reconnaissance Orbiter actually saw material tumbling down the side of a crater. So they caught a landslide in action. The middle picture, lower picture, are more sand dunes up near one of the polar regions. And then the lower right is the Mars's moon Deimos. So we have 2 moons, Phobos and Deimos. And there is Deimos with a nice big impact crater on it. So beautiful high resolution images in color, and also serving as a data relay, taking pictures of landing sites. And also, one cool thing that Mars Reconnaissance Orbiter has done is they've been able to coordinate when other spacecraft were landing on Mars. they were able to coordinate when Mars Reconnaissance Orbiter was taking a picture, and it actually got spacecraft on their parachutes. It turned and took, a series of pictures and captured other things landing with their parachute deployed. So cool. I should have had that picture. So these orbiters, part of this new strategy, looking for water, looking for signs of habitability. Here's some more pictures from Mars Reconnaissance Orbiter. Look at that, captured a global dust storm. So dust storms are of interest if you're trying to land on Mars. So there's a lot of dust there, and you don't want to land in a dust storm. So you would look at the seasonal dust storms and try not to land during those times. And spiders on Mars. These are these interesting forms called aeraniforms, which happen on Mars and are not seen on Earth, having to do with carbon dioxide ice as it escapes into the Mars atmosphere from the polar regions. It leaves these spidery cracks behind. So we love posting pictures like this around Halloweens because spiders. I better go quicker because I have already been talking too long. But in the early aughts, we had these great orbiters. So Odyssey, Mars Reconnaissance Orbiter, cruising around Mars. Now we sent more rovers, robotic geologists, to document more of the history of Mars. One of them discovered early in its mission, they were called Spirit and Opportunity, 2 twin rovers sent to different sides of the planet. One of them discovered very early in its mission these little round things, which we call blueberries. I love blueberries in my yogurt and my oatmeal. These are hematite blueberries. On Earth, these form in standing water. This is confirmation that standing water was in this place to cause these little hematite concretions, which we like to call blueberries, to form. So confirmation right there that standing water was once present in this place. These little concretions are found on Earth. So when they saw them on Mars, they said, woo. The middle picture is the edge of a crater and was found to have high carbonates, which are minerals that form in fresh water. So this was confirmation, and they found this all throughout Mars, these 2 rovers, of the presence of fresh water. And on the right-hand side, this white material that was scuffed up by the actions of a rover wheel. Actually, one of the rovers lost control of one of its front wheels, and they spent the rest of the mission driving backwards and, dragging their wheel through the Martian dirt. And they turned up this white stuff and realized they were sulfates or salts. On Earth, those precipitate out in the presence of hot springs. So this was a geothermal area with hot springs. On Earth, hot springs have all sorts of microbial life. Would that be a place to look for life, the signs of ancient life on Mars? So a hot spring and an area with calcium carbonates, all of those are places where on Earth you would expect to see signs of ancient life. These were habitable environments here. So these twin geologists lasted a long time. Spirit lasted 6 years, Opportunity 14, and they covered many, many miles on the Martian surface and continually found evidence of persistent standing, different kinds of water, acidic, freshwater, geothermal water, across Mars. And I just wanted to show this beautiful picture. Opportunity even went in and out of craters, large craters, and driving up these steep slopes. And over 14 years, boy, did they learn how to operate rovers and all of the knowledge they gained on operating these long missions of how to operate with the teams on Earth, how to work with the orbiters, how to efficiently drive a rover on the surface of Mars, and how to use better computing power and autonomy to operate your missions. So Opportunity gave us so much information about operating spacecraft at Mars, which was helpful when we sent the next one, the Curiosity rover, which landed in 2012. So Curiosity was that next step in the Martian evolution, or the evolution of our Mars program. The rovers and orbiters gave us lots of information about water. Now, Curiosity is a chemistry lab. This is an active mission today. This has a chemistry lab inside it and can analyze Martian rocks and soil. It has a drill which takes powder, rock powder, and you can see in that photograph on the sort of upper right there, a drill hole and clay minerals that have been pulled out of that drill hole. Look how different the color of that dirt is from the surface of that rock. It can take that powder, put it into instruments, and search for signs of organic molecules. So this is the habitability mission. Did Mars have organic components? Did Mars have sources of energy for microbes? Did it have enough sunlight? Did it have enough oxygen? Did it have standing water? Curiosity was looking for habitability in its crater, which is called Gale Crater. The upper right-hand picture just shows a little scoop where the drill would dump the sort of dirt, the ground up rock, into that little scoop and then put it into its instruments. Below, you can see one of its workspaces with all these interesting sedimentary rocks piled up and all the sand where it drove through, and you can see its tracks. So Curiosity confirmed that Mars was once habitable. That location in Gale Crater had all of the things that that living things would need to survive. It had standing fresh water, and it had chemical sources of energy, and it found organics. It's also had many methane readings, which we have not figured out on Mars. On Earth, methane is created by the actions of living things. On Mars, it might not be living things, but we haven't figured the methane question out. But Curiosity has found these methane spikes that happen in the spring. So 13 years on, actually earlier this month, August 5th, was Curiosity's 13th anniversary. So we call it a teenager, and this teenager likes to take selfies. So that's a selfie taken on Mars. On the left-hand side, you can see its traverse map. So that is 13 years of driving. It hasn't gone that far. On the lower part of this traverse map are the sides of a mountain. So Curiosity is driving up the sides of a mountain right now called Mount Sharp. And it's passing a junction between a time in Mars's history when it was warmer and wetter to how Mars is today, dry and cold. So it is documenting a transition between two eras of Mars's history and perfecting the art of a selfie. I decided to throw in these two other spacecraft so people wouldn't yell at me. But our MAVEN orbiter has been documenting, this is still active, has been documenting why Mars's atmosphere is so thin. Earth's atmosphere, nice and thick, we can breathe. Mars's atmosphere has been lost to space over time, and MAVEN has helped us understand more about our sun's role in that atmospheric loss. Basically, the sun's charged particles have been scraping away the Mars atmosphere over billions of years. On Earth, our atmosphere is protected by a global magnetic field. On Mars, they don't have that global protective magnetic field, so its atmosphere has been lost. So that is why Mars's atmosphere is 1% of Earth's. It's thin and dry and cold because the atmosphere was not protected by a magnetic field, been lost to space. Those two images of Mars there, MAVEN took documenting auroras, like our northern lights. Mars has auroras. How cool. On the right is the InSight lander, which is something that landed in 2018 and lasted about 2 years, and documenting Mars quakes, not earthquakes, Mars quakes, to learn about the interior of Mars, which would tell us about the evolution of Mars and of rocky planets. And you can see poor InSight, its solar panels when it landed, and its solar panels a year later with all the dust on them. So that is the hazard of working on Mars. Dust like that will be a hazard if humans explore Mars. So information from this picture is important for human explorers. Okay, we're at our last mission. Well, second to last. So this is our fifth and final rover. There are no current plans to send more rovers to Mars, but this is the last step in our 20-year exploration strategy of following the water, looking for habitability or proof that Mars could have supported life. This rover is looking for signs of ancient life. So Perseverance took another selfie. This rover, landed in 2021. So it's just 4 years into its mission. It landed in another crater called Jezero Crater, which once had a standing freshwater lake. And it had a river channel that sent water into the crater. It had a delta formation, like the Mississippi River Delta. It had an outflow channel where water flowed out. So this was a place where water was, standing fresh water. What a good place to look for signs of ancient life. So this rover has been collecting rocks. Curiosity grinds up rocks to make powder. Perseverance makes a rock core. You can see on the upper right-hand side here, there's that beautiful drill bit, which cores into rock and takes out a thin sliver of rock, kind of like a stick of old classroom chalk. It's about 4 inches long, and it seals it in a titanium tube. And the lower right shows one of the tubes laying on the surface of Mars. That has a rock core in it. And on the selfie picture, Perseverance is looking down at a rock in which it's taken 2 rock cores, or taken 2 drill holes. I forget if it took both those rock cores. So Perseverance is storing these important rock cores for a future mission to bring back to Earth. We cannot answer this question about whether life arose on Mars. We need to take these rock cores back to Earth and study them in more detail with more sophisticated instruments. So the searching for ancient life, Perseverance's step is to look for rocks that might answer that question, take the rock cores, and then hold them. And then this future mission will bring them to Earth where we can study them. So here are an example of a series of the rock cores. The rover likes to take pictures of them. And the crater floor, delta front, upper fan, and margin are 4 areas in 4 campaigns as Perseverance has been driving around. And so there are 4 areas where scientists were asking certain questions about what they were seeing and taking cores and storing them. So these are all these named samples. We've brought 43 empty tubes, and we expect to fill 38 of them. As of today, Sol 1607, Sol is a Martian day, we've filled 30 of 38 we expect to fill. So 30 of 38 potential samples have been collected. The rover is holding them inside itself, and some are sitting on the surface of Mars. So there are 2 groups of samples that a future mission could grab. Now, I did want to share this. One of these samples is the most exciting to scientists. This rock sample has a name. It's called Sapphire Canyon. They always name the rock cores so then they can refer to a name when they're talking about them. So this one is called Sapphire Canyon. And if you look in the center of the image, there's 2 white bands. And in the center of the image is sort of a mottled, spotty texture. We're calling them leopard spots. Now, that pattern on Earth has been seen in rocks that were altered by bacteria. So bacteria we're using in a chemical reaction, we're using iron to make energy. And they left these little dark circles, rings, or leopard spots on the rocks. So we found a rock that looks like that on Mars, and they got very excited about it because this matched a pattern seen on Earth. We don't know if this rock, Sapphire Canyon, was created by the actions of life, but we certainly took a sample. And this is one that we are really excited to bring to Earth, because this is the only one that really shows this possible sign of ancient life. Again, they can't answer that question yet until this rock comes to Earth to be studied. But this is the one that has people most excited. And actually, there's a paper in the journal Nature, which is a prestigious science journal, coming out in early September about this rock. So I hope we see some news about it, because this is the holy grail of Mars rocks. Woo! And Perseverance is still going, so it's going to keep driving. It's driven up and out of Jezero Crater now, and now it's going off to another area called Midway, which may have ancient geothermal vents. All right, I'm almost done. Perseverance did not go alone. It had a little traveling companion, which was a technology demo. Remember, I talked about those milestones: flyby, orbit, land, rove, fly. This is the Mars helicopter, which arrived at Mars, bolted to the Perseverance rover, to the belly of the rover. And here's its deployment and being dropped on Mars. So there's that little guy, and hoping this little video should work. There it goes. This is a video showing Ingenuity helicopter's third flight. Now, remember, I told you the Mars atmosphere is only 1% of Earth's. So the idea of flying in this tiny, thin little atmosphere was a challenge, and Ingenuity met that challenge. It was a technology demonstration, was supposed to fly 3 to 5 times. It flew 75 times. They flew it higher, farther, faster, and it lasted for about 2.5 years. It's kind of amazing. So this has opened up all these cool opportunities. This is this last milestone of this presentation. What cool other things can we do and places can we explore with helicopters? So here's coming back. So Ingenuity finally had a hard landing in 2023 and stopped flying. But it lasted, it really lasted so much longer than anyone expected. So there I've given you sort of what has come before, all of the milestones about ways that we explore, from flying by to orbiting to landing to roving to flying, and our Mars exploration strategy: seek water, learn about habitability, seek signs of ancient life. We've done all that. Now we're charting our future for the next 20 years. We are going to keep learning about Martian life. We can't help ourselves. We are going to keep studying Mars as this dynamic planet, and we are preparing to send humans. All of these robots have contributed information that will be useful to human explorers. And there's no doubt that when human explorers get to Mars, they will bring robots with them to work together. So this is an exciting time. There's a lot of talk about Mars, and a lot of talk about the human exploration of Mars. And I would love to leave you with the idea that robots will work together with humans, but they really were the precursors to these human explorers, and that they've laid the groundwork for everything we know about Mars, so that our astronauts will have an easier time and can stay safe when they get there and discover more things on Mars. And I'll just leave you with, oh, there they are. Not there yet, but working on Mars.